Okay, so on our next video, we're going to be working in Mathematics 3 in rational functions, and we're going to be talking about end behavior of rational functions. Now remember, when we get out towards as x approaches infinity and negative infinity, these first terms here, if we're in standard form, these first terms here with the highest degree are going to be really important, and then these um, later terms are kind of going to almost disappear. So we're going to keep looking at what happens with these largest terms here. So let's look at our first problem. Our first problem is negative x to the fourth plus 6x squared plus 4x all divided by negative 3x to the fifth plus x to the fourth minus 8. And again, these later terms are going to disappear. We checked that they go down fourth squared x to the first power. So our really important terms we need to look at are, let me change my color here, are negative x to the fourth over negative 3x to the fifth. And what we can see is that the bottom here has a higher degree. So the bottom is higher. So when we get out towards infinity or negative infinity, this one is going to become very high, and this one is not going to be as high. So we're going to get smaller and smaller number, and it's going to approach 0. Okay, so our first case is when the denominator's degree is higher, and in that case we're going to choose f approaches 0. Now our second problem here. Again, we check that we're in standard form first, and then if we're in standard form first, we can kind of ignore these later terms here. And the important terms are going to be negative 8x cubed over 2x squared. And this one, the numerator is the higher. So whoops. So we're going to have a very large numerator and a much smaller denominator. So we're going to diverge up or diverge down. So that's what we need to figure out. So in order to figure out diverging up or diverging down, we need to look at when we go to positive infinity, what are the signs. So when we go to positive infinity, x to the third is of a positive number. We have a positive number to the third power times a negative number, and that is going to give us a positive number times a negative number, or a negative number. And in our bottom, we're going to have a positive number squared times 2, which is a positive number. So that's going to give us a positive number on the bottom. So in the end, we're going to end up with a negative number. So if our x is approaching positive infinity, then our f of x is going to approach negative infinity. Okay, and that's this one down here. That's this one down here. As x approaches infinity, then I know that f of x is going to approach negative infinity. And let's see what happens when x approaches negative infinity. Well, I'm going to have a negative number cubed times a negative number divided by positive times a negative number squared. So this is going to be a negative number cubed is negative times negative is positive, and over here negative number squared is positive times a positive is positive. So I want to end up with a positive number here. So my f of x is going to approach positive infinity, and over here I'm going to choose, as x approaches negative infinity, f of x approaches positive infinity. Let's look at a couple more here. So here I've got, again, these are in standard form, so this stuff at the end, we're not going to worry about it. going to kind of disappear as we get off towards infinity and we look at the very far right and the very far left, and we're going to end up with dominant terms are negative 5x squared or x to the 6th over x squared. And we can see again that this side, this one is higher, so we're going to be going either up or down as we go to infinity. Okay, so let's see what happens as x approaches positive infinity. Okay, I'm going to have negative 5 and positive number to the 6th over a positive number squared, and that's going a positive number to the 6th is positive, so that's going to be a negative number over a positive number, and that's going to give me a negative number, so I know it's going down. So f of x is going to approach negative infinity. Now let's see what happens. Whoops. Now let's see what happens as x approaches negative infinity. This looks kind of like our last problem, right? Wait and see. Negative 5 times a negative number. Actually, I don't need to put that 5 over there. Over a negative number squared. And that's going to be negative to the 6th power is going to be a positive number times a negative number is a negative number, and then a negative number squared is going to be a positive number. So we're going to end up with a negative number. So f of x is going to approach negative infinity again. So in both cases, when x approaches infinity, f of x approaches negative infinity, and when f of x approaches negative infinity, when x approaches negative infinity, f of x approaches negative infinity. Let's look at our last problem. Consider the following function and determine the end behavior. So here we'll see we don't really care about this stuff at the end anymore, right? And we're going to have negative 2x squared divided by negative 6x squared. And these two have the same degree. So what's going to happen is we're actually going to cancel these out as we get higher and higher. These are going to cancel out, and we're going to end up with approaching negative 2 over, negative 6 over negative 6, and that's going to approach 1/3. So as x approaches negative infinity, we're going to approach 1/3, and x approaches positive infinity, we're going to approach 1/3. We don't have to do anything because we don't see any x's over here, so we don't have to worry about what it's going to approach or whether it's positive or negative or anything. We've canceled those out, and we have nothing left, and we just have this limit of 1/3. All right, so that's how you find the end behavior of rational functions, and I hope you're